Okay. Say welcome back. All right, while you're waiting, smash that like button, share. I've only got so many subscribers. No, actually, for years I've been thinking about doing a channel because I think if you can get a good, unique idea and you can really pump it up, there's a lot of money to be made on YouTube. I mean, there are some people that make just a ton of money, right, with channels. A couple of ones I've been watching for a while. I'm like, should have done that a long time ago, right?
You could do a calculus-based Khan Academy.
Yeah, I wanted to do more of it. Obviously, economics is. If you watch my channel, I've got a few things on there.
I like econ.
I think.
Oh yeah, econ.
Yeah. So hey, 11 o'clock. If you guys are free on Fridays, so.
I already took econ, sorry.
Well, you can just come on in. Fridays is a free for all. It's open discussion. Anybody wants to come. Yeah, happy to have you. 11 o'clock Fridays. I know you're in fitness, but if you don't have class on Friday and you want to come in before, then yeah, I'm here. There's a lot to talk about right now. So if you've seen the Nelsonomics Runs channel, then Nelson J7474, and I have a lot of unrelated. So I think if I was to do a channel, I'd have to do a separate channel because I got baby videos on there. Right? So I got a lot of baby videos on there, and I don't want to mix those. Okay. So anyways, moving on. All right, so let's pick up on section 1.9, inverse functions. And where did I leave off? Reflections. So remember that if you have a function, a graph of a function, the inverse function is a reflection about the y equals x axis, right? So the origin here. And so if your graph, so we're looking at the y equals x squared as a function, right? And because this is not an invertible function, right, because it looks like that, it fails the horizontal line test, so it's not invertible. However, if I restrict my domain to positive values of x, and then I eliminate this, and now it is invertible, and the inverse function is going to be the radical of x, right? It's going to look like that. And so it's a reflection. If I were to fold the board over the x equals y axis, you would see this would be laid on top of that, right? So again, it's just a reflection. Inverse functions are reflections of their original function over the x equals y axis. Right? What did we say? What's the domain? Domain and range. The domain of y equals x squared is all real numbers, right? Say is it like that? And then the range is y is greater than 0. But here, my domain, x is greater than or equal to 0, equals, right? And the range is y is greater than or equal to 0, right? So notice they don't match. So your function and your inverse function, the domain of your function is the range of your inverse function, and the range of your function is the domain of the inverse function, and so these would not match, right? All real numbers versus positive numbers. So that's why we had to restrict our domain to greater than 0 so that they would flip. Now I know they're the same thing there, but if you look at thinking back to some of the examples we did yesterday, right? And I'll do some more here in a second. So again, they have to be pass the horizontal line test to be invertible, and they have to be 1-to-1. So every x has a unique y, and every y has a unique x. And okay, let's do some examples here from the section 1.9. show that f and g are inverse functions algebraically and graphically. So I'll just write down the original function. I'll graph it, maybe. And f of x is 1 over 1 plus x. Note, domain, range, right? So there are restrictions to my domain and my range up there, right? The domain, what values can x take on? Anything but -1, right? And what values can y take on? Anything except 0, right? And again, y cannot be 0 because my numerator is a constant, and so my numerator could never, like set this equal to 0 and solve, and you'll find there's no solution, right? So it can never be 0, okay. And so what does that mean? That means for the f inverse, what's my domain going to be? All values such that x cannot be 0. And my range will be y cannot be -1. And so let's go ahead and find the inverse. So f inverse of x. And again, how do we find the inverse? Step 1, switch the x and the y, right? And so y equals this, and so now I'm going to say x is 1 over 1 plus y, right? Now I'm going to solve for y. I'm going to multiply both sides by 1 plus y over x. 1 plus y over x. Okay, so I'm multiplying both sides by x, right? By that over x. And note that my domain for my inverse function, x is not 0. Right, so that's my domain. I know that's going to be my domain. So when I'm multiplying by x over x, I don't have to worry about, oh, is that the little fun thing that I did in the beginning, right? So don't worry about that. So they're going to cancel. So this is going to cancel. And so I'm left with 1 plus y on the left equals 1 over x on the right, correct? Okay, so again, x cannot be 0, so check. Got my domain there, sounds good. And then I'm subtract 1 from both sides. I get y equals 1 over x minus 1, such that x cannot be -1, right? Good? And if you plug a -1 in here, -1 equals 1 over x minus 1, plus 1 to both sides. I get 0 equals 1 over x, which can never be true, contradiction. Therefore, it is correct and true that y can never be -1. Right, so that's my... Okay, any questions so far? No, everybody's good? Good, good. Okay, so this is my y inverse function. Right? This is my original function, and we could graph that. What would that look like? You could plug in a couple of values of x. I know that my original function is going to be, again, asymptotic at x equals -1, which is right here, and y equals 0, which of course is here, right? So when x is 0, I get 1 over 1. So I think it's going to look like this. Okay? This is my y equals x axis, right? And so now my inverse function is going to be asymptotic about x equals 0 and y equals -1. All right, so if I were to fold this over here, I think it would look like that, and like that. I think it should look like that, right? I think that's about what that would look like. Okay. So anyways, you've got your asymptotes, you've got your original function asymptotes, and again, asymptotic means it approaches but can never actually be that number, right? And so the domain can be anything but -1, so x can never actually be -1, so the graph would get really, really close to it, but never actually reach it, right? So and then the y would get close to 0, but never actually reach it, and then you're just flipping your domain and range for the inverse. Right? And then, okay, so we got that. Quickly, good. Now, how can I prove that they are, can you prove that they are the inverse of each other? By taking a composition, right? So if I get f of f inverse of x should equal x, should equal f inverse of f of x, right? So the composition of the function composed of the inverse is equal to the inverse composed of the function, which is should both equal x. So let's do this one first. So this is going to be f, which is 1 over 1 plus x, except x is not going to be x, it's going to be f inverse of x, right? Which is 1 over x minus 1, right? So what do we get? We get 1 minus 1 is 0 in the, right? And so I get 1 over x equals, that's going to be the top, 1 over 1, right? Divided by 1 over x, which is actually multiplying by the inverse, right? Times x over 1 equals x. Yeah, check, right? Okay.
So on the right side is inverse, and on the left side is the
Here, I took the original function, right?
right.
Instead of f of x, so instead of x here, I plugged in the f inverse function, which is 1 over x minus 1. I plugged that in there, right? And then I simplified, and what I got was 1 over x minus 1 right here, right? So you get 1 plus 1 over x minus 1, so the 1 and the 1 cancel, and then I get 1 over x, which multiplied by the inverse is 1 times x over 1, which is just x, which is what it should be, right? And then if I do it the other way around, I should get the x as well.
So you just plugged it in. Gotcha.
Yeah. So you just do the composition here.
Gotcha.
And so remember, when you're doing a composition, you're taking the outer function here, and you, instead of a function of just a variable, instead of plugging in like an x or something, everywhere where you see the variable, you're plugging in this entire function, right? Let's see if I can find it. Boy. Okay, here's the good one. I've got an f of x is x minus 1 over x plus 5, and I've got an f inverse of x is, or a g of x, it said. Find out if, it's asking are these inverse functions. So it's g of x is 5x plus 1 over x minus 1. And we want to know, are these inverse functions? So again, how do you tell? We have to run f of g of x. You run it through. If you get x, then you have to go g of f of x. And again, if you get an x again, then yes, they're inverse functions, right? So again, it's asking, you've got these two functions, and show that f and g are inverse functions algebraically and graphically. we won't do it graphically, but if you wanted to do it graphically, you would just graph them and see are they reflections about the XY axis, right? But we'll just do them algebraically. So f of g of x is f, so I'm going to plug in for where I see an x here, I'm going to plug in the g of x function, right? So again, that's going to be g of x minus 1 over g of x plus 5, right? So again, it's a function of this, okay? So where I see the x in my f function, I plug in g of x. And so now where I see g of x, I'm going to plug in the actual function itself. So that's going to be 5x plus 1 over x minus 1 plus minus 1, right? Divided by g of x, which is 5x plus 1 over x minus 1 plus 5. Okay, now we got to simplify that, right? So if I turn this 1 into an x minus 1 over x minus 1, now x cannot be 1 or negative 5 in each individual function, right? So the domain here is x is not negative 5, and the domain here is x is not 1. Okay. So notice also that the domain of this one and the range, what's the range of this one? Looks like all real numbers, right? I think. And same here with the range. Can x be 1? No, x in the range there cannot be 1. So here, notice if g is an inverse function of f, then the range of f would be, because notice the domain of g is x cannot be 1, right? So if that's the domain of my g, and they are indeed inverse functions, then the range of f should also be cannot be 1, right? You can actually plug that through and find out, is that the case? 1 equals x plus 5, and I don't. So that is going to be a little funky there, right? So yeah, so that seems to fit. Okay, so let's find out, but let's do the algebraic test. Again, f of g of x should be x if indeed they are inverse functions of each other. Okay, so continue on where we are. 5, I'm going to multiply, I need my common denominator here. Okay, everybody so far so good? I'm trying to simplify my fraction here. And then this is going to be minus x plus 1 on top, right, over x minus 1. And that's going to be divided by okay. Let's see. We have 4x plus. So simplify that, 4x plus 2 over x minus 1, and then I'm getting, yeah, 10x and so these are going to, I'm dividing these, right? So I'm going to multiply by the inverse. My x minus 1s are going to cancel. I'm going to get 2 times x plus 1 over so it doesn't look very good. Yeah, I don't think they are. Doesn't look good. Doesn't look like they are, right? Anybody see? Did I get my right? Did I write those up right? X minus 1 over x plus 5. And yeah. So this is not going to simplify into x, right? So far, they don't look like inverse functions of each other. Okay? I think I did that correct. Well, it should be though. Let's see, what did I do? Let me make sure I got everything up here right. 5x plus 1 over x minus 1 minus 1. And then plus 5, yeah. Minus x plus 1, yeah, x plus 1, x plus 1, 5x plus 1. Okay. 4x plus 2 over that shouldn't matter though. 5x 4 Yeah, I'm not seeing it. Unless I'm missing something that I did somewhere. Anybody see anything? Yes?
I don't see anything, but I'm curious. If you're just trying to figure out if they're inverses of each other,
Yeah.
could you just take one and flip the x's and the y's and see if it equals the other one?
Yeah, so you have to solve, right? So y equals x minus 1 over x plus 5, so you can set it to, and then solve for y, which is going to be hard to do, right? So y plus 5, gotta get x, y plus 5x equals, they're gonna cancel. I'll leave that there. Oops, we'll leave that x. So y plus 5 times x equals y minus 1. And then multiply it by I'm going to go ahead and multiply that out, yeah. Okay, and then minus y minus 5x from both sides, get x, y minus y equals x. Okay, so far, I'm gonna factor a y times x minus 1 equals Is that right? Right. Let me make sure. Okay, so I started with this. I switched the x and the y's. Yeah, well, again, all I was doing here was trying to show that they were, or were not, I guess, inverse functions of each other. And so if I wanted to find the inverse function of this one, then yes, switch the x and the y, and then solve for y. And that's what I'm doing here, right? So I've switched the x and the y minus 1, y plus 5. I'm going to multiply both sides by y plus 5. That leaves me with y minus 1 equals y plus 5 times x. Distribute the x, leave the y minus 1. And then I'm going to bring this to the right side and the y over here so I can group up my y's. Okay? And so I'm going to get xy minus y equals that negative 1 minus 5x. And then I'm going to factor out the y. So I get y times x minus 1. And that's going to be, and I can actually, I want 1 plus 5x. And 5x plus 1 over, and then I'm going to divide by the x minus 1. And so y negative 1 plus 5x over x minus 1. So I think it should be a negative, not a positive. X plus 1. xy plus 5x. Yeah. So I get the same thing, I just don't have the negative. I have a negative here that I don't have here. And oh, you know what? I can't read it. It looks like part of the, so it should be a negative. So they are inverse functions. That should be a negative though. There we go. So that will help a little bit, but yeah. So now I have to do this all over again, right? So sorry, I couldn't see the negative sign in front of it because if you look at it, it looked like it was part of a fraction. Okay, let me try that again. Start over. So now that I've caused thorough confusion, do this again. Okay, so f of g of x, and g of x is that negative thing. So now I'm going to go, g of x is negative 5x plus 1 over x minus 1, and then minus 1. And that's going to be divided by g of x plus 5, which is negative 5x plus 1 over x minus 1. All right. And again, I can just leave it here. And minus 1. Okay, so let me do the multiply by x minus 1 over x minus 1. Right, you can do x minus 1 over x minus 1. You can do it that way. Right, it's just 1. X minus 1 over x minus 1 is a form of 1. And what that's going to do is, in my numerator, these will cancel out. I'll distribute this to both terms, right? You guys see that, right? So rather than turn a 1 into x minus 1 over x minus 1, I can just multiply the whole thing by x minus 1 over x minus 1. And what that's going to do is, in my numerator, it's going to eliminate this one, and then I'll have to distribute it to this. And it will eliminate this, and I'll distribute it to that again. So I'm going to get negative 5x minus 1. So that's distributing my negative sign in here into the parentheses, okay? And then it's going to be minus 1 times x minus 1. So minus x minus 1. Okay? That's my numerator. And in my denominator, I'm going to get the same, I'm going to do the same thing. So I'm going to get negative 5x plus 1 So, and then minus, again, x minus 1. Okay, so what do, g of x is, what is x, yeah, okay. So okay, so this looks better. So now I'm gonna get minus 5x minus 1 minus x plus 1. So minus 1 plus 1, so those will go away. And I get minus 5x minus x, so that's gonna be minus 6x over minus 5x 1 plus 1 is 2 minus 5x minus 6x plus 2. Okay. Was that right? Minus 6x, so minus 5x minus 1 minus, and then x minus 1. And then in the numerator, minus same thing. That should be plus 1, that's why. Now, one of these, where am I? Totally losing, totally lost where I am. So it should be x minus 1, x plus 5. That should be a 5. Sorry, guys. So, can't see this on the board. It's hard for me to keep track of what I'm, all these writing on the board. Minus g of x is, again, this thing here, which is negative that, right? So I plug the negative in for x, and then I've got minus 1, and in the numerator, I should have plus 5. Right? Okay, so then it's going to be plus. So everything else stays the same, except this here is going to be a plus 5, right? Is that right? Okay, so then, yeah, okay, good. It's working out, right? So everybody see that? So then on the bottom, I'm gonna get minus 5x plus 5x. Yes, that's eliminated. And I'm gonna get 1 minus 5. Yeah, should have. So 5x plus, minus 5x plus 5x, those will cancel. And be x minus 1. X plus 1 should be a minus, right? Yeah. So minus 5x minus 1 plus 5x minus 1. So I'm going to get 6x over minus 1. Should be a yeah, minus 1, minus 5, right? There we go. Okay, got it. So after all that, then I get a minus 6x over minus 6. Those cancel. Oh, okay. All right. So I did it. Right, clear as day. That's obvious, right? I'm just kidding. Just kidding. So that's why. So some of these. I mean, when you have something with like an x over an x, it's going to be, I mean, it's obviously going to be a little bit harder to find the inverse, okay? And when you're doing that, so I made a couple of mistakes there, right? And I could see that I found the inverse, and indeed, it is correct. It is the inverse of the other by, like you said, so Logan was saying, finding the inverse of this by switching the x and the y's and solving for y, I get the same number, right? I get this. Now, to prove that it is the inverse, I need to take f of g of x, and what I was doing was missing negatives and making stupid mistakes here. I don't know what the hell I was thinking. So, had to go back and should be much more careful on here, right? So if I were to go ahead, I'd get negative 5x minus 1 plus x plus minus 1. Should be a plus 1 right there. Minus 1 plus 1, yeah, that's plus 1, because that's a minus. And then I'm gonna get, on bottom, I'm gonna get negative 5x minus 1 plus 5x, and then minus 1. Minus 5, I mean, sorry, 5 times. There we go, okay. Okay, so now I can go ahead, minus 5x plus 5x. And so in my numerator, I'm gonna get negative 1 minus 5 is negative 6. And in my numerator, sorry, that's my denominator. My numerator, I'm gonna get minus 5x. I get minus 1 plus 1, those cancel. And I get minus 5x. And that should be a minus x again, right? Minus x. So it's gonna be minus 6x. So I get negative over negative, becomes a positive. 6 over 6 is 1. I'm left with x. Okay. So after all that, talk to my editor, edit that video down, so all the mistakes are edited out. So, okay, I will, maybe I should do this, I'm gonna do this one more time. I'm gonna go the other way. So now that I've cleared all that up, right? Let's go the other way. Okay. In fact, I'm gonna do this in 2 videos.